In this video, we're going to go through a couple of antique examples here, but how we could use inequalities with linear equations or linear relationships that already exist to kind of describe a set of solutions or a set of things that would necessarily satisfy some sort of given situation that we want to satisfy. So let's take a look at these couple examples. You notice this one here, it says the weight W, and we're going to measure this in pounds of a fish, is given by this. So we have W, which is the weight of the fish in pounds, is equal to 10.4 times this variable T, minus 2.2, where what we say is T is the age of the fish in years. So what I guess we could say is this, we say, go ahead and write this down. We say W is our weight, and we say weight, and T is time. Okay. It says describe the ages of a group of fish that weigh up to 29 pounds. Okay. So here's the deal. It says T is the age of fish in years, and what we want to do is we want to describe the ages of a group of fish that weigh up to 29 pounds. So when we say up to, let's start with this. What do we really mean? Do we mean equal to 29 pounds or up to 29 pounds? I guess what would that mean? It could be anything below that or at least up to it. Okay, so I suppose what we could say here is this. If T is the age of fish in years, T is time, and we say describe the ages, so describe time of a group of fish that weigh up to 29 pounds. The interesting thing is this. They're telling us about the weight, but asking us to describe time. So what we're going to do is this. We're going to say, well, if fish weigh up to 29 pounds, we're going to say, well, then their weight could be no more than 29 pounds. It could be 29 pounds. It could be less than 29 pounds, but it couldn't be more than that. So when they say that they weigh up to 29 pounds, it basically interprets into this sentence right here. But what they want to do is have us describe the ages of a group of fish. And the nice thing about this is we have a relationship between the weight of a fish and the age of a fish. So what we can do is we could say, well, if I know that W is less than or equal to 29, but W is actually equal to this statement right here, then what we can do is we can actually go substitute this W statement in down here using a T instead, essentially. So what we end up with is this. We say, well, really, instead of W now, we're going to write this. We say 10.4 T minus 2.2. Now, keep in mind that we do want to describe the ages of the fish, okay? So when we say ages, we say, well, time represents age, okay? So what we need to do now is this. This is good right here. This is a wonderful thing we just did. But now what we want to do is we want to isolate T, okay? So isolate T, which is the time in years, okay, or age of the fish, I guess, okay? So we're going to say 10.4 time, or times the number of years, minus 2.2 is less than or equal to 29. I suppose if we want to isolate T, we'll start by adding 2.2 to both sides. So if we add 2.2 to 29 there, it looks like we get 31.2, and this is going to say, well, 10.4, let me remake my 4 here, 10.4 T is less than or equal to 31.2. And then we could divide both sides by 10.4. Now, I don't know, does this go unevenly? I think it does, actually. 10.4 goes into 31.2. We could check it on a calculator, but certainly, and kind of reason it out here, but we say 3. And so what I want to do is I want to label this, first of all. When you have a word problem, you have to label all the time. We said 3 what? Well, time is time, or T is time. This was measured in years, we said. Okay. But what we want to do is interpret this result. So what we're saying is this. If a group of fish, their average weight is up to 29 pounds, then using what we already know about the weight and the age of a fish, what we've seen in the past due to our data, we say if that's the case, then we could say that the fish, if they weigh up to 29 pounds, are likely 3 years old or less. Okay. So again, let's take a look at one more example here. It says the percentage of households H. So let's write this, percent of households having cable. Okay, so we'll write that down there. H is the percentage of households with cable. But we say it's modeled by this. We say H minus 2.3Y plus 44, where Y is the number of years since 1998. And as a matter of fact, I think, let's see, it says describe the years when the percent is less than 53.2. So I think I might have had a typo here, but I think I mean to write H is equal to 2.3Y plus 44. Okay, but Y is the number of years since 1998. So we're going to write this up here. We say Y is the number of, always important to write number on variables, or percent, but we say number of years, okay, since 1998. So this is kind of an important thing. When we say since 1998, let's write a little thing down here. We say year equal to 0. When would year 0 be then? If we're saying, well, that's the number of years since 1998. Keep this in mind here, that this would be really 1998. Okay, so when we say y equals 1, we really mean 1999. Y equals 2 is 2000, and so on and so forth, okay? So I just wanted to point that out there, but we have to keep that in mind. But it says this, describe the years. So we want to describe the years. Which one is that? Is that H or Y? So we want to describe Y when the percent, so we say the percent. Well, what is percent? Percent was H. When H is less than 53.2. And notice that they use less than here, just less than. So we're going to write this out. We're going to say H is less than 53.2. So if that's the case, the percentage is less than 53.2, we want to describe Y, but we already have this relationship again here. We say H equals 2.3Y plus 44. And if that's the case, what we can do again is go ahead and substitute. That's what this is called when you plug in two things that are equal, one for the other. Okay, so we say, all right, well, this would be less than 53.2, and we have 2.3, let me rewrite that there. 2.3y plus 44. So again, let's go ahead and solve this one out. We say subtract 44 from both sides. In this case, I think we get, let's see, 53.2 be 9.2. I think here, so 2.3y is less than 9.2, and if we divide both sides by 2.3, this one I think I also designed to go in evenly as well, and it does, and we say 4. Okay, and again, this is a word problem, so we need to label this, and of course y represented this, the number of years since 1998, so we'd say y is less than 4. Okay, and let's think about this. 4 years after 1998, what year would this be? This would be kind of equivalent to saying y is less than, or kind of like before, and we say 4 years after 1998 is 2002. So basically, we'd have to say y would have to be before 2002 if this were the case, if the percentage were less than 53.2%. Cheers.